Okay, this video is going to cover the review for the surface areas and volumes of prisms, cylinders, cones, and pyramids test. So we're going to start with, we'll go through each conic. We're going to start with the pyramid. We're going to start with the prism. And we'll go over the formulas for each one, and then we'll get into examples for each one. Okay, so prisms. We're going to talk about surface area and total area because those are interchangeable. There's two bases, right? So it's 2b plus pH or 2b plus the lateral area, which is that pH. You're not going to have questions on your test that ask you directly for lateral area, so you're going to go all the way to total area, which is why I'd probably say that this is going to be more common. What's going to change here is how you find the area of the base and the perimeter depending on the shape. The volume is base area times height. So if I look at a rectangular prism, we usually have something like length, width, height. And so if I'm going to find the total area or the surface area, 2b plus pH. The base area, because the base is a rectangle, you can pick the top, the bottom, the front, the back, any of those. So I will pick the bottom as the base. And so its base area would be 4 times 5. Which is 20. And then I also need the perimeter of the base. So 2 times 4 plus 2 times 5, or 4 plus 5 plus 4 plus 5, which is 18. Now total area is 2 times 20 plus the perimeter, which is 18, times the height of the prism, which is the one measurement we haven't used yet, 3. This would be 40 plus 54. Or 94, and it would be unit squared. I think I've said it a couple of times, but I'll remind you again that if it's multiple choice, you're going to see the units on it. If it's not multiple choice, it's going to be open-ended. You're just going to write 94 as your answer. All right, then volume is easy for a rectangular prism because it's length times width times height. So it'd be 4 times 5 times 3, or 20 times 3, which is 60. And again, it would be units cubed. If it didn't have, if it was multiple choice, you're going to see the units. And if it wasn't, you would just enter 60 in as the answer for that question. All right, when you look at a triangular prism, there's actually two different kinds of triangular prisms. The first could be a equilateral or an isosceles. In this case, we could say that this would be an equilateral one. So if I know the sides, let's say the side was 3, and the, actually let's make it 6, and then the height is 10. If I want to find the surface area using 2b plus pH, the base area would have to be 1/2 ANS. So you'd have to find the area of your equilateral triangle. If this is 6, this would be 3 and 3. If I divided my 360 by 3, I'd get 120. This would be 60, 30, 90 here. So this would be your opposite, your 60, and you'd get 3 over root 3 for your apothem here, or 3 root 3 over 3, which becomes root 3. So I'd get 1/2 A, which is root 3, N, which is 3, length of each side, which is 6. 1/2 of 6 is 3, and I'd get 9 root 3 for the base area. So surface area would be 9 root 3 plus the perimeter, which is 6 plus 6 plus 6, or 18, times the height, which is 10, and I'd get 18 root 3 plus 180. And again, whatever that units is, units squared. For volume, base area times height, we already know the base area, again, 9 root 3, the height times 10, and this would be 90 root 3. Okay, if it's a right triangular prism, then it's still the same formula, 2b plus pH, but you'd see something like 3, 4, let's say. And to find, this would be total area or surface area, okay? To find B, I have to do 1/2 base times height. So 1/2 the base, which is 4, the height, which is 3, or 2 times 3, which is 6. That's the base area. And then because it's a right triangle, I can find the hypotenuse. This is a triple 3, 4, 5, which means the perimeter, 3 plus 4 plus 5, or 12. So 2 times 6 plus the perimeter, which is 12, times the height. Oh, sorry, I didn't add it on. Let's again say that that's 10. So it'd be 12 plus 120, 132 units squared. Then for volume, okay, if it asked, it'd be base area times height. Base area was 6, height is 10, which would be 60 units cubed. Okay, now the last one is if it's like a regular polygon. For example, this one is a 1, 2, 3, 4, 5, 6, a hexagonal prism. So for these, we'll probably go relatively easy on you. If you had to find the apothem, that might be the only thing. So let's say that, again, this is 6. Let's say this is 10. If you're using a hexagon, then at the top would be 60. You'd cut it in half. This would be 30, making the A3. And this would be 60, making the apothem A root 3, which would be 3 root 3. So then the base area would be 1/2 3 root 3, number of sides is 6, length of each side is 6. So you can do half of 6 is 3, this is 9, times 6 is 54 root 3 for one base. So the the total area, 2 times the base area plus the perimeter, which is 6 times 6 or 36, times the height, which is 10. Total area, that's 108 root 3 plus 360, and it would stay like that. Okay, you also might, if it's like a hexagon, a pentagon or something else, you'll be given the apothem. There'll be no sine, cosine, tangent, that stuff on this. Then volume would be the base area times the height. And the base area is 54 root 3 times the height, which is 10. So this would be 540 root 3 units cubed volume. Okay, so that's pretty much what you might see for a prism. Okay, again, looped in surface area and volume. Then came the pyramids. Not necessarily in the order that it was surface area and volume of each one, but we had surface area or total area of the prism, which is 1b plus 1/2 the perimeter times the slant height. And then for the volume, we had 1/3 base area times height. So if you are doing areas, you're going to need the slant height. If you're doing volume, you're going to need the height, which is where a lot of the Pythagorean theorem comes into play here. If it's a square pyramid, you might see something like 4, and then let's say that this is 3. For the volume, that's all you need, but for the area, you're going to need this slant height. So depending on what it's asking for, again, if it was just volume, you'd already have all the information you need, but if it was area that you're trying to find, you're going to have to say that this is cut in half, so that's 2, because it's half that 4. And then the hypotenuse would be the slant height, which is going to be 2 squared plus 3 squared, 4 plus 9, 13, and then the slant height would be the square root of 13. So if it's area, you need the slant height. If it's volume, you need the height. So let's say I use this for surface area. It would be b plus 1/2 perimeter times the slant height. The base area, if it's a square, would be 4 times 4, which is 16, plus 1/2 the perimeter, which is also 4 times 4, 16 times the slant height. And I'd get 16 plus 8 root 13 units squared. And it would be kept like that for surface area because one's got a square root and one doesn't. And then for volume, 1/3 base area times the height. 1/3 the base area, 4 times 4, which is 16. The height is 3. 1/3 and 3 cancel, and the volume would just be 16 units squared. Or cubed, sorry. Okay, now you've got a rectangular pyramid. So let's say, okay, so the rectangular pyramid, remember we had to do it a little differently for surface area, so you're actually not going to see it for surface area. You would have to find the area of the base, which let's say that this is 6 and this is 2. You'd have to find the area of that, which would be 12, plus the area of the front 2 triangles, the back 2 triangles, add them all together. So you're not going to do that. But let's say you do have volume. And let's say you get this. The volume would be 1/3 the base area times the height. So 1/3 times 12, which is the base area, times the height, which is 4. 1/3 of 12 is 4, and 4 times 4 is 16. The good news is that's really all you're going to see as far as the pyramids go. You might have to use the Pythagorean theorem to find the missing side for the slant height or the height, but it's not that bad. Okay, then came cylinders, which also I think are the easiest. Surface area or total area is 2 pi r squared plus 2 pi r h, which is the lateral area. And the volume is pi r squared h. So for these, the trickiest thing they could give you is maybe they give you the diameter is 10 instead of just the radius being 5, but they still have to give you the height. So if that's the case, then surface area or total area would be 2 pi 5 squared plus 2 pi 5 times the height is 6. 2 pi 25 plus 2 pi times 30. And I get 50 pi plus 60 pi, or 110 pi. And again, it would be units squared for the area. And then volume, pi r squared h. Pi 25 times 6, or 150 pi units cubed. So that's if it's kept in terms of pi. If it wasn't, if it actually asked you to use pi on your calculator and then round it, 110 times pi would be 345.57. So it would be 345.6 if it was to the nearest tenth. 150 times pi would be 471.23, or 471.2 if it was rounded to the nearest tenth. That's cylinders. Okay, then we get to cones. So for cones, total area or surface area is pi r squared plus pi rl, which is the lateral area. And the volume is pi 1/3 pi r squared h. So just like your pyramid, you'll be given the height or the slant height. You might have to find the other one using the Pythagorean theorem or the Pythagorean triples. So for example, if you were given, let's say this is 6, this is 8, I would know the slant height is 10. So you want to definitely review your triples. I'll do that again when we're done with this one. So the total area would be pi 6 squared plus pi 6 times the slant height, which is 10, 36 pi, plus 60 pi, or 96 pi. And then volume, 1/3 pi 6 squared times the height, which is 8. 1/3 pi 36 times 8. So 1/3 of 36 is 12, and 12 times 8 is 96 pi units cubed. So totally a coincidence that these have the same answer. That's not usually how the case is, but it is possible. Okay, so you could also have composite where they put two shapes together, or take a part away, which was in both of the notes for the last section. Just keep that in mind. So triples, you want to review you want to make a note of 3, 4, 5, 6, 8, 10, 5, 12, 13, 7, 24, 25, 8, 15, 17. These are the ones that we've seen the most, okay? It doesn't hurt to put that on your formula sheet so you have quick access to it when you're looking through your questions. It doesn't mean that they're all going to be triples. You might have to complete, like, do the Pythagorean theorem. For example, if this was 10 and that one was 8, then this would no longer be 10. You'd have to figure out that other side using the Pythagorean theorem. But they could be, they're definitely going to see at least some triples. All right, so again, remember that your test is on Thursday. You can use the calculator and your notes as reference, but I would condense your notes so you're not digging too long and taking up the time. At the end, you're going to submit your work, so I would also say you want to have scrap paper, or you need scrap paper. And you need 2 devices, one to access the Zoom meeting that is not your iPad, and then the iPad to take the actual test. All right, good luck studying, and I will see everybody soon.